Greetings, I'm Mike Kearney from the Space Infrastructure Foundation, and I'll be walking us through this next discussion on the OAIS Interoperability Framework. The goal of this standards development effort is to enable interoperability for archives, whether they are OAIS conformant or not. And the reason for this, improving access to archives means our data is more reliably preserved against disruption from things like technology changes. Across the board, it enables more accessible and more understandable preserved digital assets. The vision is for a common interface for users when accessing many diverse kinds of content in archives, as well as archive-to-archive interoperability. Given the broad acceptance of OAIS, we think OAIS-IF will provide longer-term access because well-known OAIS-IF resources, adapters and such, can be harnessed for access to legacy data in archives well into the future. And a side benefit of this approach will also be enhanced capabilities for cross-discipline research because of the broader access to more users to archives that they previously didn't have access to. There are many definitions of interoperability, which we won't go into here, but our goals for interoperability are to improve users' access to archives, users meaning both producers and consumers. And also we expect to provide archive-to-archive interoperability, and we believe this can be done simply with the same interfaces as used by producers and consumers. And this should enable transfers between archives of preserved data as well as the supporting representation information. One thing to bear in mind is that CCSDS defines standards, not the software itself, with the exception of prototype software to verify those standards. We'll discuss that more as we go along. For OAIS-IF, we plan to produce a set of interfacing standards, but not specify the underlying function of the software, except as needed to describe functionality visible at the interface. The plan is to develop protocols and APIs which can be used by developers to create software adapters to enable interoperability. Our standards development methodology includes using UML models, which we hope can be made available later to developers that are building compliant systems to these standards. I think that's really a breakthrough approach that will widely benefit people who implement OAIS-IF systems in the future. And CCSDS requires us to develop 2 independently developed prototypes for every normative standard. So we hope to make those prototypes, prototype software, available to archive developers as well later, perhaps even open source. Consider the scenario where there are many different clients wanting to bring together data from many different archives. They could be archives or other systems. And consider that these archives are widely different: science, web, archives, engineering, humanities, and apparently number 5 is the Mike Kearney archive. And client 1 wants to talk to the first 3, so it needs to install the circle, triangle, square software. Client 2 needs to install the triangle, square, diamond software, and client 3 needs to install the square, diamond, and my rounded rectangle software. So what's transferred across that interface is usually whatever the archive has, usually simple files, and it relies on the client having the appropriate software to make them understandable and interpretable. Our vision is that each client should need only one adapter at their location, and with that one adapter, they should be able to talk to many archives with their adapters. And each archive with one adapter at that location should be able to talk to many users or clients. What's exchanged in this scenario is OAIS information objects, which are exchanged in a standard way, and they include not only the object of preservation, the data object, but also some representation information to interpret and validate that data object. And the key point is that instead of requiring the clients to have lots of versions of software, they only need one user adapter. And any solution that strives to avoid requiring expensive modifications to user software or archive software will need to use adapter type software layers. So that's what we've done. So let's discuss the resulting cross-discipline capabilities that you gain with this OAIS-IF architecture. With interoperability to many more archives, we expect that users will have access to archives and data that are normally outside of their field. And this integration of multiple disciplines will certainly produce new, more useful information, breakthroughs in technology and research and other advancements. But understanding that data from that other discipline is key. And the OAIS information model allows the channeling of information, representation information, to support that by transporting rep info as information objects, by integrating rep info from many sources, even outside of the target archive. And this ecosystem will enable access to descriptive rep info from many locations to make preserved data understandable even outside the discipline. And the potential result is more breakthroughs in research and discoveries. Now to talk about some additional desired characteristics of OAIS-IF by comparing it to HTTP. Now, I am not about to try to explain to a bunch of web archivists how HTTP works. This is just a comparison discussion. So HTTP has been successful because of certain loosely coupled characteristics. We want the same characteristics in OAIS-IF. For example, a browser that talks to many servers, one-to-many, multiple users with different clients can retrieve from one source, many-to-one. Archives and clients should be able to use their current software with adapters. And we plan for OAIS-IF to do the same. However, there are differences. A web browser simply displays the content without guaranteeing the interpretability of that data. OAIS-IF meets OAIS requirements so that it can channel the data to allow the user to be able to interpret the data by sending more interpretable information objects, by using an OAIS-IF protocol instead of HTTP, which especially knows how to handle representation information, and by using OAIS-IF servers instead of web servers, since only they have the rep info understanding that supports the interpretation of the preserved data. Now, this is a simplified illustration of what the differences are in the goals of our project. Bear in mind that a web browser simply displays what it gets, pretty much like a document, as I said, whereas OAIS-IF is concerned more generally with data. Imagine scientific data and being able to use and interpret that data from many sources. Instead of HTML-based web pages crossing the wire, we want to send more general OAIS information objects. And instead of HTTP protocol, we want an OAIS-IF protocol which enables the handling of representation information. And this means that instead of web servers, we have OAIS-IF servers which have the ability to create and handle those OAIS information objects. The question is, how can we make this as simple and painless as possible to minimize the modification of existing software for users and archives? And the answer is the use of adapters. Now to describe the high-level functions of the components of the OAIS-IF architecture. Keep with me, there's a fair amount to go through here. So there is existing user software, which is your current applications that are specific to a user's discipline, the software that we hope we don't have to modify. Then there is the user-specific adapter that adapts that software to the next function, the user generic adapter. The user specific adapter may be sensitive to information content that is unique to a user application or a user community. How to handle astronomy photos, for example. It will be sensitive to at least the structure of the representation information, if not the content. Then we have the user generic adapter, which basically prepares the information to cross the communications infrastructure, abstract transaction functionality, puts and gets, etc. Then there is the COM infrastructure, which of course the data crosses to get from the user location to the archive location. And the first thing it encounters at the archive location is the archive generic adapter, which mirrors the functionality of the user generic adapter and does those same transactions, the basic communications transactions. Then the archive specific adapter adapts the interface of the generic adapter to the user software. To a degree, it understands the content of the information objects like the other specific adapter, such as repackaging the archive's request to match the user's data request. And the archive software, of course, is the existing or legacy software at the archive that hopefully will remain unchanged. The switchboard is a new functionality. There needs to be a resource that describes to a user how to talk to any given archive. It may point to where adapters can be downloaded, for example, or it may point to a starting screen at the archive. Normally this would be part of the originating archive, but our architecture must accommodate the ability for it to be remote. So in the architectural baseline, it's shown as remote. Next is the registry, which is included here because there may be a need to access additional rep info from outside of the originating archive. This registry of supplemental rep info may be another archive or simply an archive-like registry run by a designated community. There may be negotiation to allow the user to request more rep info or to have it transformed into an alternate format. This supports the cross-discipline capabilities that we referred to earlier. The red squiggly lines indicate the interfaces that we expect to define as part of the OAIS-IF specifications and standards. Of course, we don't know what all user software looks like, so we can't specify that interface. Ditto with the archive interface, but we will specify these interfaces on either side of the generic adapters, and the ones on the COM-facing side of the generic adapters are actually the same interface. And data flowing down these paths are the information objects in accordance with the OAIS information model. Now to talk about the resources for developing your own OAIS-IF instantiation. There is, of course, existing user software and existing archive software, which should be able to be unmodified. There are the user-specific adapter. Because of the dependency on the legacy user software, user developers will have to develop most of these, but we expect that they can be shared across discipline communities. For example, a community like web archive users or developers. CCSDS will develop a prototype which hopefully can be made open source and available for download. And as a hint, someone in the web archive community should be able to develop the user-specific adapter that would work for most web archive users, which can include scientists, not just web specialists, but scientists from outside the web archive community that will want to download your adapter. So generic adapters, both of them on the user and the archive side, we expect them to be common for many archives and communities. CCSDS plans to produce at least a prototype of a user generic adapter and an archive generic adapter. and we hope to make them available to the community as well, again, possibly open source, so that the user and archive developers can capitalize on them. The archive-specific adapter the archives will need to produce their own software for this interface, of course, but again, we hope for a CCSDS prototype to be made available as a starting point, and we expect that some communities of archives, those that use a certain commercial product, for example, can share what they developed or buy commercial adapters. But the best case is that they can use the CCSDS prototype and simply configure it. In other words, filling in some tables, and maybe it'll work if the archive interfaces are generic enough. Both registry and switchboard will have to be developed by archives or a third party at a remote location, and many would consider these to be part of any archives job, but as I said, our architecture accommodates remoteness. For adapters, these guys will probably use the same adapters as the archives that they supplement. To sort of frame the functionality of these adapters, generic adapters cannot be clever. They don't understand the content details of an information object. They transport the information between the user and the archive and don't interpret it. That's why CCSDS should be able to create these for general use for most archives. Specific adapters need to understand at least parts of the content and how to handle it. User groups and archives will likely have to create the specific adapters, but we will have some example implementations, and as I said, hopefully open source, so you can take the open source code as the primary basis of your specific adapters and just adapt it to your user or your archive interface. I should also mention that we're developing UML models, as I said before, and those UML models should be a resource for developers, archive and user developers, to develop specific adapters. So what is the path forward? What's next on our to-do list? First, of course, more work is needed on the analysis of the requirements and interfaces. We're doing that with our UML models, which should be great news for future developers. Then developing the primary specifications that define the interfaces for architecture, adapters, all of these functions that are components of the overall architecture. Then develop the 2 required prototypes for each normative specification that we end up producing up here, and that will prove the interoperability, after which the documents can go through the approval cycle and be published. And then also we'll produce other documents, informative documents, supporting documents to help with rationale, guidance, scenarios, etc. I should also say we welcome any help that your community wants to give us. Join our team and help us with all of these tasks that's on our to-do list. And in particular, prototypes would be good. They're always a challenge for a standards organization, and an implementing organization like yours that has background in developing web tools and such would be wonderful to develop the 2 prototypes that can go on to be web archive tools for the rest of your community. So, in summary, OAIS-IF will improve the preservation of our digital assets by providing interoperability, enhancing access, and for both users and archives. And for archives, it enables the preservation strategy of handing archive information packages from one archive to another. For example, if one archive is going out of business, its preserved assets can be easily transferred to an archive that takes on that job, thereby improving the preservation of those that content. It will make it easier for more people to be able to use and combine information from many sources. meaning the cross-discipline research capabilities that we've explained. And by doing that, it makes all information that is preserved better accessible and more valuable. So that's our explanation of our OAIS-IF project. Thanks for listening, and we hope that you understand it a little better and will support us as we develop and deploy these OAIS-IF standards. Thank you.